Hello world, scientists and engineers. Today I'm going to be working a statics problem involving friction. And before I get started, I want to tell you about my sponsors. So my sponsors, they run this website called Contest Celebration. And what that website is a picture-based contest. And they give out about $500 a month to the winner. So you go on there, you make a profile, and see if you can win. So, let's get started. So let's say that we have a car here, and it's got some rope on it. The owner is not too excited at all because his brakes failed and his e-brake failed also, but he just so happened to have some rope and he wrapped it around the tree before the car has passed him up. And now what he wants to do is see how many times he has to have this rope wrapped around this tree so that he can let this car roll down at a constant rate. Maybe there's a flat surface down here or something and he doesn't want to let it go because it might hit another car or land in some water. Maybe there's a shark or something like that, So, that's a bad shark. So that's what we're going to do. So, let's see. Let's say that the mass of the car is 3,400 kilograms. And I will be using the metric system for today. And let's say that the coefficient of kinetic friction around the tree, including all the rolling here with the wheels and whatnot, let's say it all comes to 0.3. And let's say this guy is pretty strong. Let's say he's me. So the force that he can put out, or that he can withhold, is let's say the force of the man that he can withhold is 300 newtons. So that's what he can hold. And we want to find out how many times he needs to wrap it around the tree. So that would be contact with this rope and the tree, and the symbol we use for that is beta in this equation. So the equation is tension 2, which is after contact, which would be this tension right here, T2, is equal to T1, which is the tension before contact with your friction force, times natural log number to the power of mu, which is our friction, times beta, which is the angle of contact. So that's what we're solving for. So let's see what we got. We need to solve this equation for beta, and then we can get started. So the way you do that is you need to isolate everything and get everything off of beta. So divide both sides by T1, so give you T2 divided by T1. This cancels out on this side, equals e to mu beta. Further solving will give us natural log T2 over T1 is equal to mu times beta. So beta is equal to 1 over mu times natural log of T2 over T1. So we have almost everything that we need here. We know this force here, right, that this guy can output is 300 pounds. We don't know what the tension force here in this rope is. So the way we do that is we have to calculate the component of weight that's acting on this rope. So we know weight goes down, and I'm going to draw my frame of reference here along this axis, and since this is rotated by 20 degrees, all I'm doing here is rotating it by 20 degrees, from a normal frame of reference that you might see people drawing. So we have to break this weight into its components for this axis. So this is 20 degrees in here. This side will be, this is the opposite side of the angle, so we know we're going to be using sine when we multiply. So let's plug in. So we have 1 over 0.3 times the natural log of the second tension, which we've already calculated, not calculated, but we already have. It's 300 newtons. And that's going to be all over this force. So this force is going to be the force of gravity and with the x component. So it will be opposite of our frame of reference. So we'll put a negative here. So that's going to be 3,400 kilograms times the acceleration of gravity. It's 9.8. And that's meters per second, and then multiply that by sine of the angle theta to get this component, because that's the only thing that's acting in this direction, so that's what the tension will be. So it's sine of 20 degrees, and we plug that into our handy dandy calculator, and that gives us 12.1275 radians. So now radians, most people don't have a real scale for that, so to go convert from radians to revolutions, you just divide by 2 pi, and that gives you 1.93 revolutions. So this guy would need to wrap, after he's already wrapped it, to make it stop, he would need to unravel it, but have at least or almost 2 full revolutions around the tree with contact with this rope. And then he could lower his car at a constant speed and get it down to a flat surface safely, no crashing, no nothing. I mean, it's a good chance that he bought a Chevy, and that's why it broke down, because they don't know how to handle bailout money. But anyway, guys, this is the answer. So go check out contestcelebration.com and make a profile and see if you can win that $500. All right, guys, up and out.